So I do this for a living, as it was mentioned previously. Usually I do this to industry groups, whether it's the CIO organization in Canada. I have a role that's, although it's a CTO for Canada, I have a North America role. So I essentially live on a plane. I take about 100 flights a year on an average. And essentially what I do is I work with our clients predominantly in the financial industry to help them develop their strategies for investments in information technology. So specifically things such as cloud computing, around analytics, around machine learning, emerging technologies such as big data, serverless computing, hiring processes, what they should be investing in, etc. So that's kind of my background and what I do, and I've written a bunch of books on these topics. I have about 15, 16 issued patents so far. Usually so I'm a technical guy at heart, number one. But don't be afraid. What I've tried my best to do is to keep it at a level of interest that commerce students would be interested in. The objective for me here is to give you a little bit of background about cloud computing, the history, and really try to relate it to you as to why you guys should care. And so we'll talk about history, we'll talk about what the heck cloud computing actually means, so what's the industry definition, how you can translate that definition into real terms. What are the benefits and risks, so why are companies doing it, why is the marketplace doing it, and then we'll come, kind of by way of a long introduction, we'll come to why as a business student should you care about cloud computing. So hopefully after the first 10, 15 minutes or so, I'll keep your interest enough so that I'll be able to answer that question. But I got to give you the background so that we can answer that question reasonably well. I'll then talk about some of the examples of cloud computing in daily life. Hopefully none of that should be eye-opener. Maybe it'll just give you some more information in a slightly different fashion. And then the last 3 to 4 minutes or so is going to be hopefully a mind-expanding exercise in where we think and where the industry thinks that technology is going. So IBM is a $100 billion company. We are, by some measures, one of the largest research organizations in the world. We have a whole bunch of PhDs and research fellows that try to figure out where the industry is going and where the marketplace is going. So I thought, cloud being such a central technology, if I could give you some examples on evolution of technology and how our lives are going to change. So as business students, you can then figure out what are the areas where you guys can either make money or help other companies make money or help them keep track of their money. That should be some areas of interest, right? All right, so without further ado, so let's just start with a quick history lesson. So back in the 50s, 60s, when my dad was working, time sharing was developed. So computers did not used to be as small as what you guys have. Companies such as IBM and what was known as the Gang of Five used to make these computers called mainframes, which I hope you guys have at least heard about, which used to be the size of this room. And they were obviously extremely expensive to the point that there are some infamous quotes at the time that the world would only require 5 computers because of the size and expense of them. And then the concept of time sharing came into place, where the idea was you can take a big computer, but because the computer is so fast, it can run multiple jobs at once. And by the way, that same technology is embedded into all of the computers that you guys are using, whether it's the laptops, the iPads, the phones, the watches, or any of the embedded devices. It's the exact same concept that goes. 1969 was another seminal moment when the research universities partly funded by US Department of Defense came up with the concept of ARPANET. The intent was to connect all of the universities together, so have better information access, better flow of information. The idea was to have a worldwide web of information that was available to researchers. And of course, at that point, there was no product, there was no internet. This is a time where if you had a question, you got to go to the library, get hold of a thesaurus or a dictionary, or they used to have these things called Encyclopedia Britannica, download that, take that off the shelf, flip the pages, figure out what you want to do. So this is what led to was the precursor of the internet. 1977, another big seminal year, the IBM PC came out. Didn't used to look anything like that. Rather big, rather bulky and boxy. But the microcomputers, as these things are called, they were then available for the mass market. This is when the people like Bill Gates then had the dream of having a computer on every desk. And by the way, people laughed at the time. Why would people need a computer on their desk? Now I imagine you cannot spend a day without touching a computer, or an hour if you have a cell phone, which I'm sure everybody does. 1990s, another change happened. This is when people tried to figure out how can we have these microcomputers connected to each other. Again, remember, internet has not existed yet, right? So you rewind the clock back far enough, ARPANET exists. Researchers and universities can talk to each other. People have these things called dial-up modems, which would make these huge cranking noises. And if you watch You've Got Mail or any of these other Hollywood movies of the time, it takes a long time to go download a single message. You can't send the attachments. There is no iPhone. There is no FaceTime. None of that exists. So 1990s, the backbone or the infrastructure began to develop to actually enable what has become broadband at the time. So what you see on the screen here, these are the network cards. Every computer has those. That's what enables your computers to talk to each other. 1997 was the first time ever that the word or the term cloud computing was coined. So this is Ramnath Jalapa, who's the professor at University of Texas, who wrote what I think was a seminal paper where he essentially talked about a new computing paradigm. So again, let's rewind the clock back. Now we are in mid-90s. A lot of people have computers. I think I had a 80286 or something at the time, which was probably like 1/50th of the power of what you guys have here. By the way, 8026, 80386, these were the computers that were used to send the first man to the moon. So it's not about how fast your computer is, it's what you can do with it. Anyway, so he came up with this concept of cloud computing, and his definition of cloud computing was it's a paradigm where the boundaries of computing will be determined by economics rather than the technical limitations. So this is the first time ever somebody's come up with an idea that, okay, so long as you have money to be paid, essentially a credit card, people should have access to limitless computing. So this is all theory. 1998, another key company was born, VMware, if you haven't heard about them. They really revolutionized the concept of virtual machines. So the idea is that rather than have, on the left here that you see is the traditional architecture where you have a super big computer, big metal server, you lay down your operating system on it and then you run your applications. Well, their idea is we're going to have the VMware stack in between and we will have logical computers, logical segmentation of computers. 1999, another company called Salesforce was born. This is the time I had my first startup that failed miserably. We lasted 3 years. But Salesforce at the time really revolutionized the world. So internet has now existed. People are beginning to use broadband. So we have some reasonably fast computers. We have those old Nokia brick phones. They had come out. This was the first provider or the first Silicon Valley-based company that came up with and that was successful at delivering software over the internet. Typically, otherwise, if you are a Microsoft or an Apple fan, you would have to go to the store and buy lots and lots of floppy disks. I'm sure you guys probably don't even remember or know what those things are, or CDs or DVDs subsequently, and then use those to load software onto your laptops. And then 2006 really is when the cloud computing evolution well and truly started, when Amazon, rather than trying to build computers to just sell books and all the other things that they sell, that they decided that they're going to have computing made available to everybody. So this is really where you could have, you could be sitting at a Starbucks, and if you want a server to run a job, any workload of any kind, whether it's to analyze some data, run some spreadsheets, or if you have some P&L analysis that you want to do, you can go get a server from Amazon, run it for a couple of hours, and shut it down. All right, so far this is all what the industry is going on. Governments have absolutely no idea yet as to what the heck cloud computing is. 2011, enter the government. So this is the National American Standards Institute. It's a US body that kind of defines standards. So if you ask a government representative what cloud computing is, you get this definition that nobody can make any sense of. Anyway, so that's the history lesson, quick so far. So what do we actually mean by cloud computing? Very simply, there are 5 key characteristics that define or that really help you understand what cloud computing is. Number 1, that is, it is on demand and self-service. So you don't have to go ask an IT department or some system administrator to give you access to a server or to give you a machine that you can work on. This was a revolutionary concept at the time because This is prior to this, people would have to wait 6 months to get access to a server on which they could run a job. It's got to be rapid, it's got to be elastic, so it's got to be able to be tuned up and down. So as an example, if any of you guys watch American football, there are a lot of tweets that go in, as the game progresses. And a lot of the companies, they make their decisions on what ads they're going to play at halftime. So this is real money being involved, based upon the sentiment that they are analyzing, based upon the tweets that are being sent. And in a typical NFL Super Bowl game, by halftime, there is about 1.5 to 3 billion tweets that have been sent for that topic. So they have to get access to all of those tweets. They have to, these are all text tweets. They have to analyze those. So they need vast amount of computing power. And they need it to very, very quickly. And obviously they can't build all of that. I mean, if you just invest all the money in building all of that up front, that's a lot of investment. So rapid elasticity. It's measured service. So essentially it should be like a utility, like how you go to the pump and you pump your gas. You pump 10 liters, you pay for 10 liters. You don't have to pay up front for 100 liters or your full tank, as an example. It uses location independent resource pooling. So essentially you don't care where the computer is, just give me access to a computer. Right? I just want to run a job. I don't care where it is. Physically where it is, I have absolutely no concerns about it. And finally, it's got to have ubiquitous network access. So essentially, regardless of where I am in the world, I should be able to access that service right now. So if any of you guys, here for example, we connect to the internet, use LTE or whatever other network we have, we can connect to IBM Cloud, Google Cloud, Amazon Cloud, whatever, and we can get going pretty quickly. So for business students, it's very important, in my opinion, to understand what it is that we mean by cloud computing. There's also this concept of what kind of a delivery model it is, whether it is infrastructure as a service or a platform as a service or a software as a service. It's the same stack that you see, all the 4 pillars. So on premises, this is in your own data center, like the York University's own data center, they're responsible for everything, top to bottom. If it's infrastructure as a service, the cloud provider, so a third-party company, will give you everything up until this layer. Beyond that, the consumer has to manage. And then as you go further to the right, you have to do less and less. Fundamentally is what it is. If any of you guys are using Gmail, for example, you don't care what Google has to do behind the scenes to keep Gmail updated, patched, do all the security, all the backup. You log into your laptop, to your phone, on your watch, any other embedded device, your email is just there. You move a phone from Android to iPhone, your email is just there. Behind the scenes, Google has to do a lot of work to ensure that it is available, it is protected from viruses, it is backed up, and all of that. So that's what this chart represents. Another way of looking at it at IaaS, PaaS, and SaaS is who's the consumer. So SaaS is the easiest thing to consume. End users like you and I can go in and consume it. So that's the Google, the Office 365, the Instagram in a way is a SaaS offering, for example, Facebook, etc. You're just consuming a piece of software. You could also have another version of that, which is a platform as a service, where essentially it's a bunch of tools that are available for developers. So if any of you guys are coders here, any programmers in the room? One. So if you guys are ever writing any scripts or using any programming languages like Node.js, Java, JavaScript, Python, PHP, Ruby on Rails, etc., there are lots and lots of flavors of cloud available where you can get the entire thing as a service. There's a lot more nuances there, but let's just keep it at that level. Or you can just give me a server and I'll figure out everything else that I want to do. That's your infrastructure as a service. So SaaS is what you use. PaaS is what the developers use, and IaaS is what the IT departments use. Why would companies want to use this? Well, number one, they don't have to upfront invest into a huge amount of infrastructure. So it's very cost effective. You pay as you go, so you pay as much as you use. It's elastic, so they can rapidly scale. They can fail fast, fail quickly. So rather than take a 6-month project to figure out should they invest into a certain piece of technology, they can get the servers up, run their data model, for example, and if it doesn't work, they can kill it completely. What are the risks? Security still remains, even though this is 2017, security remains one of the big concerns because it's my data that I'm going to be storing in some other cloud. I don't know where that cloud is. Maybe, so if you put any of your assignments on, for example, onto a Google Drive, the chances of that data leaving Canadian borders are quite high. Now, if you put that into a business context, if you have your health records onto a cloud that's hosted in the US, which essentially means now the US government can access your health records. Now, that's not acceptable to, well, us as citizens of Canada, for example. So skills, so security, location and control, those are some of the concerns around the risks and concerns for cloud. All right, so long meandering introduction as to why do you care. Hopefully now these things will begin to make sense. So if you look at the state of the market, so there's some radically big numbers here. The annual compounded growth rate for cloud is at 19%. This is our economy. If you look at the Canadian economy or the US economy, that's about between 2 to 3% growth in a good year, usually less than that, right? The overall market worldwide for 2015, or up until 2016 rather, was $67 billion, slated to grow up to $162 billion by 2020. In Canada alone, the projection is that by 2020, we're going to have 1.2 million IT workers. These are high-paying jobs that are going to be working in cloud computing. So you should absolutely care. This is the fastest growing area of technology. If you plot the S-curve of cloud adoption and how much money is being made or invested, it is one of the steepest S-curves that you'll find for any technology. There is not a single organization that I have come across in the last 2 years that is either not experimenting with cloud or are already there. Most organizations today are using, on an average, 5 clouds. So that's why, even though you may be commerce students and not necessarily IT focused, it pays to know what the IT department is doing, because the IT budgets tend to be big. And that's where you can have a lot of influence on where the companies invest, why they're doing so, how investments into these strategies would impact their overall strategy, for example. Some other cloud facts, some of the drivers, etc., that I talked about. Almost 70% of IT spend around the world is going to be on cloud. IT today is almost $1 trillion industry, $1.2 trillion approximately. These are huge numbers, regardless of which geography that you look at. And I think that's why you should care as to why we should be interested in cloud, or at least be aware of cloud computing as a technology. Canada alone, we are looking to double our investments, or expenditure rather, into cloud. 5.5 billion Canadian dollars by 2020. Those are huge numbers. What the other side of these numbers that I haven't explicitly stated on the slides is that there is a huge demand for skills. Not just technical skills. Technical skills obviously are important, but skills around vendor management, skills around contract management, skills around negotiation, skills around figuring out a business case, skills around figuring out applicability of a particular technology to an organization's imperatives, for example. So if you're using any of these technologies, you're using cloud. So as soon as you woke up, before you woke up today, you were using cloud. That's a known fact. I'm sure that you guys all know all of these logos. So if you look at, for example, Netflix, 37% of all of internet traffic in the US flows through Netflix. They are the single biggest traffic generator in the world. And guess where they run their servers? Obviously on the cloud. I had a customer of ours that came in and they required upwards of 20,000 virtual machines or servers to solve a particular problem that they had. So when you have problems in gaming, for example, or problems in processing genomic data, there is no way that no company today that's going to go up front and buy 20,000 servers to solve a particular problem. You rather go to a cloud provider and you consume it as a service, and once your business problem is solved, you move on. WhatsApp, it's the single largest, biggest messaging platform, who are 300 plus million users at this point, runs in the cloud. Well, it happens to run on IBM cloud at this point. But I just wanted to give you some example. Twitter, Pinterest, Google, well, all of Google products, YouTube, single largest cloud platform by some measures. Again, all cloud-based technologies. So going on to the future outlook. I talked about cloud. I talked about some of the analytic technologies that are happening today. What I wanted to take the next 3 to 4 minutes is where I think the technologies are going to go. So within IBM, what we're seeing is cloud becomes the enabling platform for a whole bunch of other type of technological use cases to come on, use cases around AI, use of robotics. So we have, as an example, IBM's own robots working with Hilton, where if you go to a Hilton hotel to check in rather than a human, you have a robot. And you can talk to the robot understands English. I think 6 languages the robot understands at this point. And all of this data is being delivered onto the cloud. If any of you have parents or relatives working in the hospital industry, the hospitals have this robot called the tug. So the hospitals have, between different floors, they have to move a lot of equipment, they have to move a lot of medicines, drugs, and they have to make sure that everything's secure. There are parking attendants who always get a lot of hate from the people because nobody wants to pay parking tickets. There's a company in the US in Philly that's come up with a parking robot. It's a 400-pound gorilla that obviously nobody's going to be messing with. I mean, it looks like a gorilla too, but it's a robot. If you look at all of the mapping applications, they're all delivered through the cloud. So there are now cloud companies or companies in self-driving or autonomous cars, as they're called, where you can summon your car. You might be in San Francisco, the car's in New York. You summon the car will navigate itself, refuel itself at fueling stations without human intervention, and come to where you are. All enabling technologies delivered by the cloud. So AI and robotics are obviously some of those areas. The other evolution of technology that we see is towards use of robots and drones in even areas such as farming. There's a Canadian company that we're working with right now, and what these guys do is they buy these Landsat images. So Landsat is a satellite that goes around the Earth, and it comes back to the same point on Earth every 16 days. And it takes a snapshot of the Earth from the sun, from its orbit, and then we apply, we download it to the cloud. We apply a lot of AI on it to figure out if a particular feature, if that's a golf course or just a dry patch of land, because the municipalities have regulations that you can only build that many number of golf courses in a certain area. Or we can sell that data to farmers that, okay, if you have a 10 million or a 100 million acre farm, you only need to refertilize a certain portion of that farm, for example. So these are some of the, like for example, the lettuce bot. So it's a robot, there is no human in that. So this one here, it's a self-driving robot. There is no human involved there. And it goes on, does all the tilling, plants the plants, moves on, communicates back to the home base as to what type of a soil grade there was, schedules another bot to come in that will go in and deploy the fertilizer, for example, schedules the times for the next drip schedule to be made. These are all technologies that are being delivered via the cloud. Driverless cars or autonomous cars. UK, Canada, US, they've all started experiments on self-driving trucks. So no longer are you going to have potentially tired drivers who have been driving for 11 hours and you see these lorries misbehaving, or, well, I'm from the UK, so the trucks misbehaving onto the highways as an example, but these are going to be driven by robots. Again, a technology that's enabled by the cloud. We have self-driving vehicles now, so obviously I'm sure you guys all heard about Amazon drones. Uber starting Uber taxis without the driver, for example. So Uber with Tesla, autonomous cars, now you no longer have taxi drivers even. So it's going to be a very different world compared to what we know today. And I just wanted to tell you that the underpinning technology of all of that, so here's my final slide. The companies to watch out for, even for example in air transportation, it's all going to be influenced by technologies such as cloud computing. So I hope some of this was interesting to you. If you guys have any questions.